Welcome to the STEM Pathways podcast, where we delve into the fascinating world of science, technology, engineering, and math. I'm your host, Rohan Sharma, a passionate explorer of all things STEM. Each episode, we bring you captivating stories, cutting edge research, and inspiring interviews with experts and enthusiasts who are pushing the boundaries of innovation. Whether you're a student, a professional, or just curious about how the world works, join us as we unlock the mysteries of the universe and explore the endless possibilities of STEM. Let's get started. Today, I'll be interviewing Michael Fischer, who holds a master's in Aerospace Engineering from the University of Michigan. How are you doing today?
I'm doing well. How are you?
I'm doing good. Thanks for joining me on the podcast. So to start off, I wanted to ask, what made you choose your major for your bachelor's?
Yeah, thanks for having me. I guess to start off, I'll mention that I was aerospace engineering for my bachelor's and my master's, and that was kind of something that I had my heart set on for a long time leading up to even going to college, probably even before high school. Um, my family and my parents kind of instilled education as a value from a very young age, and I had this kind of knack for how to build things and particularly flying machines. And so I was really interested in airplanes, rockets, spacecraft, all that kind of stuff. And so by the time I got to college, that was kind of a no-brainer, and it's kind of the biggest reason, I guess I would say, why I ended up at the University of Michigan for the aerospace program, and um, ended up having a great experience. So don't regret any of it.
Yeah, so let's get right into that. What was your experience like while at Michigan?
Michigan was fantastic. Best 4 years of my life so far, early five, because I spent an extra year there doing the graduate degree. Michigan's a fantastic place. Ann Arbor as a town was a ton of fun. The program is top notch, and I met some really great people along the way. The first 4 years I spent doing undergrad, had a great experience both in class, and then there's tons of extracurriculars that you can get involved in at Michigan. So I was involved in a handful of them. Within the department, I was involved with an aircraft design team. We called it MSAVE, where we designed autonomous, remote controlled aerial vehicles to try to address a need with delivering humanitarian supplies in communities of need. And that taught me a lot about both team leadership as well as engineering technical and solving technical problems in the aircraft side of the engineering world. And then I was also involved in the NASA Pathways program as an intern for a few different rotations while I was in my undergrad and then into my grad degree year. So then I did a 1 year master's that was kind of an add-on to the undergrad program. It's another great thing about the Michigan aerospace degree is that you can just add a year and you can basically count. You can start taking graduate classes during your undergrad and count those for your grad degree. And so I did that program and had a great experience with it, and finished that up just a few months ago, back in end of April. So
Yeah.
overall, it was really great. I miss Michigan already, that's for sure.
So while getting your degree, did you do any internships?
Yeah, so like I mentioned, I did. I guess I'll start from kind of the earlier years of college. I did one on campus in a research lab where we looked at smart materials. It was called the Aerospace Materials Lab, and that gave me kind of a look into the academic research world, and that was great. And then once I was a junior, I applied to the NASA Pathways program and got in, and that brought me down to the Johnson Space Center in Houston, Texas, and I did 3 total rotations while I was in school. One was in the mission planning group, where we basically had our hands in the mission planning operations side of all human spaceflight missions. And then I moved over my second rotation to the engineering propulsion group, where I was involved in a couple of CubeSat projects, and those actually ended up just launching to space over the summer on a Firefly rocket. But yeah, that was a really fun project because it had heavy intern involvement, so they let the interns um, have a fair bit of responsibility. So I was on the prop team for that, and we built a cold gas nitrogen thruster system to allow the CubeSats to maneuver around in space. And then my third rotation was with the flight dynamics operations group. So that's the trajectory operations team here at the Johnson Space Center. And with that, I worked primarily on SLS and Orion products for the operations team. And then I put together some code for the SLS ascent team. So that's basically what they're going to use in conjunction with a ton of other tools to help support decisions regarding aborts and trajectories on the way uphill to space for future Artemis missions. And I can go into any more of those details on those prior experiences if you'd like to get more specific.
Yeah.
But the Pathways program in general, I guess I'll just put in a word for it, was really where I got my start, and it's how I ended up here full time today.
For an aerospace engineer, how important do you think internships are?
Oh, they're huge. Definitely huge. It's you'll hear it a lot, and it sounds a little bit cliche, but you learn just as much in internships and extracurricular experiences as you do in the classroom. And so it's really a good chance to take the fundamentals, the math, the science that you've learned in the classroom from your professors and apply that toward actual real world projects. And I know that kind of sounds like cliche and what everybody will tell you, but it really is true. You spend 10 weeks over the summer or 16 weeks in the spring if you do a co-op, and you learn a ton in that short amount of time. And you get to contribute to real world projects. So not only that, but internships allow you the opportunity to network with professionals in the field. And so here at NASA, there's some of the smartest aerospace minds in the world that you get to work alongside and have as a mentor. And again, the Pathways program is terrific in that they assign you a mentor for every internship that you do. And you work directly under someone that both assigns you projects and then helps you along the way, both with navigating the technical side of your project as well as the center and the agency as a whole. And so you learn a lot about the industry, you learn a lot about how to solve challenges that real engineers face in the real world. And you learn a lot about kind of how to navigate a career through your internships too. And you learn like what you like and what you don't. So not only helpful for, finding jobs in the near future and advancing your career in the near future, but it helps you think long-term and kind of set the path for your long-term future. So highly recommend searching out internships while you're in school.
Yeah, can you actually talk a little more specifically about what you did at that internship? That sounded really interesting.
Yeah, sure. So the Pathways program is a little bit unique. It's NASA's, flagship internship program that they market as a path to full-time employment opportunities. And so by design, you get to do multiple rotations, and they encourage you to do those rotations in different groups so you can explore different disciplines. And so I guess I'll start with the most recent, because that was, I think, what's most related to what I do now and most related to my degree as well. And that was with the Flight Dynamics operations team. So there's a ton that they do. They do both trajectory for the Orion vehicle, which is the crew capsule for deep space exploration. And they also do trajectories for the SLS rocket, which is the launch vehicle that carries Orion to space. And so I got to work with both of those. And a lot of what we do is we worked, for the easiest description, we're the mission control team responsible for the trajectory of the rocket and the spacecraft. And so when the full-time folks, they train and they put together products to use on console for real-time operations. And so that means like when the rocket or the spacecraft is in the air, there are people in mission control at all times that are operating and looking after the vehicle. And then off console, there's a ton of work to do to prepare the procedures, to prepare the displays, to prepare the contingency scenarios, and as well as the operation software to prepare for those on console scenarios and make sure they work when real-time scenarios demand those products. So that was really a great experience. And I'm in an adjacent group now full-time and owe it all to what I learned during that internship. As well as what I learned in my previous internships with the prop team. Worked on CubeSats, and CubeSats are a great educational tool and scientific tool to be able to leverage, lower cost and potentially higher risk and certainly shorter timeline technologies and get them in space. So our CubeSat, for example, was built on a very rapid timeline and it was launched very cheaply to space. in order to test out hardware and iterate on that process. So normally spacecraft take years, if not decades, to get through the development cycle and into space, whereas a lot of times CubeSats can be developed in a matter of years or even months. Is the goal for a lot of these CubeSat programs, with largely off-the-shelf hardware that you can iterate rapidly on with each design cycle, whereas you really don't have that opportunity in a lot of aerospace settings, which makes them great for universities. It makes them great for an intern project, because you can learn a lot faster and you can do it with a lot less resources. So I was very fortunate to be a part of that team as well. Um, and then my first rotation again was the operations planning team, and we're in charge of basically the timeline for what the astronauts do on the International Space Station, as well as the flight plan for the Artemis missions. So, as my first internship as an introduction to human spaceflight, that was really tremendous in making me understand like how things work and how the missions get planned, and how everybody interacts, because that group really acts as an integrator between all of the other disciplines in the flight control team. Um, Hopefully that answers the question. I know that wasn't super detailed, but hopefully that explains a little bit about what I did in those internships.
Yeah. So with a job like yours, I know that a lot of schools don't have aerospace engineering programs, and people will have uh, other similar majors. How similar are they, and how different would it be if someone wanted to do your job with like a mechanical degree or something like that?
Yeah, that's a great question. It's a very good question because you're right. A lot of schools don't have aero or don't have any specific, a lot of the more niche disciplines that people may be interested in. And what I would say is honestly, adjacent disciplines that a school offer will most likely be just fine in getting you to where you want to be. For me, I really did want to study aerospace in particular, and that was something I knew before college, and so I sought that out as um, a criteria in selecting my school. But plenty of the people I work alongside have degrees in mechanical or electrical or physics or even math, and they've gotten where they want to be as well. So I guess it does depend on what exactly you want to go into and what your desired education level is. There are certain fields where a PhD is encouraged or even required. The position I'm in, that's not the case. It's certainly helpful to have higher education, but not required in a lot of the aerospace world. Um, but it depends. I guess if you're working in propulsion, which is what I do now, mechanical engineering is just as useful as aerospace engineering, and in some cases, depending on what subset of propulsion you're doing, mechie might be an even better degree to have. But if you're doing orbital mechanics, um, the mechie programs usually don't touch on orbital mechanics quite as much, but sometimes like physics or astrophysics will touch on orbital mechanics, and that's also a path in, or even just applied mathematics is a path to some of those disciplines. So I would say it depends. The other option is you can always go and get a master's or a PhD in a more specified field, depending on how your interests evolve while you're in your undergrad. Um, I think aerospace was a great option, and if you know what you want to pursue falls under aerospace, I'd say go for it and try to find a school that has it. But if you're going to a school that doesn't have aerospace, and you're interested in the aerospace sector, you can certainly get there with the mechanical engineering and electrical engineering degree, or again even physics and math. So it doesn't, your degree itself doesn't necessarily restrict you in what you can do after, as long as it's related, I would say.
So if you had to give one piece of advice to someone wanting to go down a similar path as you who's still in high school, what would you say?
Another great question. Let's see. Well, I would first say set yourself some ambitious goals. Don't don't count yourself out for a goal that you would dream of, but don't think you're cut out for. I would say if you work hard enough and you make sure you value the people you meet and try to um, just learn everything you can in school, do your best, and dream big. I guess is the number one thing. Dream big, work hard, and anything's possible. But in a more practical sense, day to day, if you do well in school, you seek out opportunities extracurricularly. That's probably the most important, like actionable thing you can do. at least in college, is seek out those extracurriculars, and more importantly, even once you're involved in extracurriculars, be it internships or project teams or clubs or whatever it is, become a leader in those activities. Find a way to take on a leadership role or offer to help someone, because that's really how you can learn the most and also get noticed. And those are both important things, because if you can have experience leading teams and leading people and, um, becoming a team player and understanding how to operate in the real world, that's going to be a really valuable skill for your entire career.
All right, then. Thank you for joining me on the podcast.
Absolutely. Thanks for having me.